Randomness is important. If you're a millennial like me, at one point in your life, you might have thought that planking and the Harlem Shake were so random. It was cringe, but we didn't know any better. Well, turns out computers are also pretty bad at being random, except they have an actual excuse. Why are computers bad at generating random numbers? At their core, CPUs are deterministic state machines. Give them the same inputs and internal state, and they'll spit out the same output every single time. That's intentional. We want software to be predictable and reproducible. But it means asking a computer to be random is a contradiction. There's no random instruction that just pulls chaos out of the silicon. Or, as John von Neumann put it, anyone who attempts to generate random numbers by deterministic means is, of course, living in a state of sin. So what are these random numbers we use when we write software? They're called pseudo-random numbers, outputs from algorithms like the Mersenne twister or linear congruential generators. They produce sequences that look random through clever math, but they're fully deterministic. Each sequence starts from an initial value called a seed, and the same seed always produces the same sequence, every single time. For most use cases, that's totally fine. Shuffling a playlist, rolling dice in a video game, running simulations, procedural generation. You don't need true randomness. You just need something that looks random enough. By the way, if you think you're learning something, leave a like. And if you've got questions, the comments are open. I read and answer them, and the good ones sometimes turn into entire videos. Now let's look at the seed again. Every pseudo-random sequence needs one, and where you get it from matters. The lazy default is to grab the current time from the system clock, which feels random but really isn't. If someone knows roughly when your program ran, they can narrow the seed down to a handful of options, then predict your entire random sequence. This isn't theoretical. Early versions of Netscape's SSL, the system used to secure online transactions, were broken exactly this way. A great algorithm with a bad seed is still broken. So let's say we need more randomness. Maybe we have some serious security requirements. Since computers can't make randomness themselves, we have to borrow it from the physical world. Engineers have come up with some creative ways to harvest that chaos. One approach is to build randomness directly into the hardware. Modern Intel and AMD CPUs include an instruction called RD-RAND that produces random numbers from thermal noise, tiny, unpredictable fluctuations in the silicon itself. It's right there on the chip, and it's generally a more truly random method. It is slower than conventional pseudo-number generators, so it should be used only when needed. The bigger concern is that RD-RAND has had real security issues over the years, including bugs where it silently returned broken values, which is about the worst possible failure for a randomness source. Another interesting approach is that Cloudflare, the company that routes a huge chunk of internet traffic, has a wall of around 100 lava lamps in their San Francisco lobby. A camera films them, and the chaotic motion of the wax, combined with any movement the camera catches, gets turned into entropy that helps secure encrypted connections across the internet. As Mitch Hedberg would have said, it's great if you really like encryption and want 100 of something. So yes, computers are not good at generating random numbers because it goes against how they work. But as engineers, this is the kind of task we have to solve. To become a better developer, consider subscribing to the channel. I do quick videos exploring topics like this, but I also do deeper dives like how not to store money in code, and the upcoming video, how to store money in code. We have so much interesting stuff coming. Bye!